Hello everyone, my name is Frederico Montes and I am a PhD student at the Process Group with the PhD title of In Silico Process Design and Evaluation Tool for Pharmaceutical Processes. Today I'll be talking about data-driven control for batch crystallization process. Now, if we look at the patent life of one API, since it is patented, you take a lot of time to do medical experiments until you actually can start developing the process for the mass production of it. So it's critical that you make the fastest design, but as well the best one you can within such short time in order to have profits. Now with modeling tools and data-driven methodologies, you can actually shorten the time that it takes to move from lab scale to pilot and pilot to industrial scale by taking into consideration as well the uncertainty that comes from previous stages. For instance, the crystallization happens to be one of the most critical processes in the pharmaceutical industry, namely because it is solid-based processes, it's very hard to model, and it's hard to get the specific kinetics. You can have errors coming from the lab, you can have process disturbance coming from before, and then you have a probability space of everything that can happen, and the crystal properties are very important. Now, for the strategy that we present is only based on data. The model is created online with the data you're collecting. And what is what you really want? Do you just want to have a measurement of what's going to be the predicted error in the future, or do you want the model to take control over you? Do you know anything about the process already that allows you to choose which kind of transfers you want for these neural networks? Do you have lots of data, or do you are just collecting data as you go? And based on these strategies, you can actually control the process without needing anything but just online measurements, and you don't need disturbance measurements either. But for further details on this subject, let's have a talk at my poster.